Welcome back to Unraveling Human Physiology, where we try to make physiology easy for you to understand. Today we are going to talk about buffers. Have you ever suffered stomach heartburn? The pain of having something like burning inside your stomach? Then you take some Tums and ooh, the relief! There's no more heartburn anymore. No more burning feelings. So, how are Tums working? The problem with your stomach is that you are producing too much acid, and Tums are a buffer that act neutralizing stomach acid. When stomach acid is neutralized, you don't feel that heartburn anymore.
pH buffers are crucial for the regulation of body pH. But what is a pH buffer? A pH buffer is any substance that can bind in a reversible way to hydrogen ions and resist better than water a change in pH. pH buffers are usually weak acids. Remember that weak acids coexist in an equilibrium with its conjugate base, and the magnitude of the weak acid and conjugate base depends in the acid dissociation constant of the weak acid. As in pH, it's better to transform the acid dissociation constant to pKa, which is minus the logarithm of acid dissociation constant. The proportion of the buffer as an acid or a base will vary according to pH. Look at this graphic of the ratio of the base and acid forms of the buffer according to pH. If pH equals pKa, half of the molecules of the buffer will be in the acid form and the other half in the base form. If pH is higher than pKa, this part of the graphic, pH is high, that means hydrogen ion concentration is very low. Then hydrogen ions tend to go free and most of the molecules of the buffer will be in the base form. On the contrary, if pH is low, this part of the graphic, concentration of hydrogen ions is high, so the molecules of buffer are easily protonated, so most of the molecules of buffer will be in the acid form. If you see this part of the graphic where pH is near pKa, a little change in pH would make a huge change in the proportion of the buffer in the acid form or the base form. But if you go to the extremes, this part or this part, a huge change in pH won't change the proportion of the buffer in the base form or the acid form. That's why a buffer is good to maintain pH when the pH you want to maintain is similar to the pKa of the buffer. So here's a key point. The maximum buffering capacity of a buffer is when pH is near the pKa of the buffer and you have a high concentration of the buffer. It is easy to understand buffering capacity with some examples. Have you ever worked in a lab? As a student in a lab, I was always asked to prepare buffers. To do so, I have to, in some point, adjust the pH of the buffer. If the buffer has a low buffering capacity, like for example a phosphate buffer, adding just a drop of an acid or a base, depending on what is needed, will be enough to adjust pH. On the contrary, with a high buffering capacity buffer like trees, for example, you will have to add lots and lots and lots of acid just to be able to adjust pH. I personally hate to prepare trees buffers. An important property of the buffer is that they react instantly, so they are the first line of defense of the body when there's a change of the acid-base equilibrium. For example, if lactic acid rises, protons will rise and pH will lower. Then if you have in the blood, for example, some buffer as a base form with sodium as its contra ion, because sodium is the most common ion in the blood, this buffer will react with lactic acid and you will have lactic acid as a salt, and in this way it won't the acid of the lactic acid won't be bothering the rest of the body, and we'll have the buffer united to the proton, and then the proton will be not free anymore, and then the pH won't change. In that way, pH normalizes. So here's a key point. Remember, buffers are the first defense of the body when something is trying to change body pH.
Summing up this part, we can say that buffers are any substance that can bind in a reversible way to hydrogen ions and resist better than water a change in pH. We reach maximum buffering capacity if pH is near the pKa of the buffer and the concentration of the buffer is high. And very importantly, in the body, buffers are the first defense of the body when there's a change in the acid-base status. Hope you have enjoyed this video, and I invite you to give me a like and subscribe to my channel. Bye!